Hello students, I am Professor H.R. Saini. I have done my MSc from IIT Delhi and MPhil from Guru Nanak Dev University, Amritsar. Then I joined the postgraduate department of physics of DAV College, Jalandhar. I served there for about 40 years. I have been guiding the students appearing for IIT, that is JEE, AIMS and other competitive examinations. My today's lecture is for the students of class 9th and the chapter is motion. And in this chapter we will study the equations of motion for a uniformly accelerated motion. Now acceleration is defined as the rate of change of velocity, that is acceleration is equal to change in velocity over time, change in velocity divided by time. The acceleration can be uniform or non-uniform. If the velocity of a body changes by equal amounts in equal intervals of time, however small these intervals may be, then the body is said to have uniform acceleration. And if its velocity changes by unequal amounts in equal intervals of time, then the body is said to be moving with non-uniform acceleration. Here we are going to derive the equations of motion when the acceleration of the body is uniform. So suppose a body has initial velocity u. This is the initial velocity. And the final velocity of the body after time t is v. This is the final velocity after time t. After time t. And a is the uniform acceleration of the body. Uniform acceleration of the body. By definition, a equal to v minus u divided by t, or on cross multiplying we get v minus u equal to at. Now let us take u to the other side, or v equal to u plus at. This is the first equation of motion for a body having uniform acceleration a. So this equation is used for finding the velocity of a body whose initial velocity is u, uniform acceleration a at any time t. Now the second equation of motion is s equal to ut plus half at square. This is the second equation. S equal to ut plus half at square, where s is the distance traveled by the body in time t. Now as you know, u is the initial velocity and v is the final velocity of the body. Therefore average velocity of the body equal to u plus v divided by 2. And distance equal to average velocity into time. Average velocity multiplied by time. That is s equal to average velocity is u plus v by 2 and multiplied by t. But you know that v equal to u plus at, and therefore s equal to u plus at divided by 2 multiplied by t. Or you can say that s equal to u plus u is 2u plus at divided by 2 and multiplied by t. Or s equal to 2u by 2, that is u, plus at by 2, that is half at multiplied by t, or you can say that s equal to u into t, that is ut, plus half a t into t is t square, so plus half a t square. So that is the second equation of motion. The third equation of motion is v square equal to u square plus 2as. Let us derive this equation. We know that s equal to ut plus half at square and v equal to u plus at. v equal to u plus at. To derive this equation, we have to eliminate t from these two equations, and therefore from this equation I get or at equal to v minus u, or t equal to v minus u divided by a. Putting this value of t in equation 1, we get s equal to u into t, and t is v minus u divided by a plus half a into t square, that is v minus u divided by a and square of this. Or you can say that s equal to, now v minus u by a, v minus u by a common, v minus u by a common, and in brackets we are left with u plus half a into v minus u by a, v minus u divided by a, bracket closed. Or you can say that s equal to v minus u divided by a into, this a goes with this a, and we are left with u plus v minus u divided by 2. This is further equal to v minus u by a into, यहाँ पे LCM आ गया 2, and we are left with 2u plus v minus u. This is further equal to v minus u divided by 2 into v, and 2u minus u is u, so v plus u divided by 2. Or you can say that s equal to v minus u into v plus u divided by 2a, or s equal to, now this is a minus b into a plus b, that is a square minus b square, that is v square minus u square divided by 2a. Or you can say that v square minus u square, v square minus u square equal to 2as, or v square equal to u square plus 2as, and that is the third equation of motion. So we have derived all the three equations of motion for a body moving with uniform acceleration. Now the high yield point to be kept in mind is that these equations are true only if the body is moving with uniform acceleration. So that's all in today's lecture. I hope you have enjoyed my lecture.